Let's talk about the fluff fill. So you are given the image, which is going to be n by n, and it represents a pixel, right? And pretty much you are going to give the original pixel, and then you are going to give the position, which is starting the float, and you will just spread out, right? So here's it. So you're starting at this location 1 1 1, right? And then if there is the value which is equal to the float center, then you will get change to 2, change to a new color 2, right? So in this one, the neighbor is what, 1 2 3 4 5, right? And so the only so here's it. So you are only impact 4 different directions, but once there's another value which is getting changed by this one, right? You'll have to change this value, right? So the old color should be the same, and you will just change to a new color. So if the neighbor is not the same color, you are not going to traverse the neighbor anymore. The only thing is you traverse your neighbor if your neighbor have the same color, right? So just getting an update. So I'm going to talk about 2 solutions. One is using the DFS, the other one is using the BFS. So DFS is pretty simple, and just keep traversing the 4 different directions, and then this will be the solution. So just keep making sure you know the old color and new color. And yeah, let's just start coding. So if the current, so I'm going to say if the current source and if the current position value is equal to the color, which is not going to change the entire grid, then I can just return. So imagine this 0 0, right? 0 0 0 0 should be this one, right? So I'm just going to draw 0 0 0 0 at position 0 0. The color is 0. Then you just return the entire grid, right? Now again, you need to traverse the DFS, and then later I will return image. So what do you need? Public void DFS, and you definitely need a 2D array, right? You definitely need a old color. You definitely need a current X and current Y, and also the new color, which is going to be represent color in this node, right? So I need to pass in my image. I need to pass in the starting position, right? Sorry, which is all colors, starting position color. So image SR AC, and the starting X is going to be SR. The starting Y is going to be AC, and then the color you want to change, right? And this is it, right? So I will say traverse. I will traverse my image old color. I'm not going to change my old color, and then I need to traverse the upside down, right? I mean ups, down, left, right? So image old color X -1, Y color, DFS image old color X, Y +1 color, DFS image old color X, Y -1 color. Okay, at some point you will get out of bound, right? So if X is actually what, equal to the image.length, or X is what, less than 0, you will return. You don't need to traverse. And same idea for Y. And let me just Y, and the length should be what, something like this, right? And also what, if the image is X, Y does not equal to what, the old color, I will have to return. So this is going to be pretty much it. Now I need to update my color, the current position color, if they are actually equal, right? If they are actually equal. So I'm going to say image XY is equal to what? Is equal to color, right? So if they are the same, I'm going to change, right? And then once again, you only impact your 4 different direction, up, down, left, right, up, down, right? And then you'll have to traverse again based on your neighbor, which is the 4 different direction cells, and impact the other four different direction neighbor, right? But only if you have what? If you have the same old color, which is the original one, which is 1, right? So this will be the solution. So let me see. Wrong. Alright, submit. This is a DFS. So let's talk about time and space first. So you are not allocate any space, right? So the space is constant, and you are traversing every single one of the cell in the matrix. So it's going to be all of n times m. So n represent the row, m represent the column. So here's the note, like DFS times space n and m. Alright, so this is the solution for DFS. So let's talk about the BFS. So BFS is going to be using the iterative solution. So you are going to use what? The queue, right? So just a quick idea. I mean, you definitely know what does BFS mean, right? So I'm going to have a queue. So I'm going to traverse the 4 different directions if they have the same color. So I push into the queue, right? So it's going to be 0, 1, and then this is 1, 0. And that's it, right? At the beginning, I'm going to do like this because I push this one into the queue first, and then it will impact these 2. And I will pull this one 0, 1, 0, 1, which is this one, right? And I'm going to check 4 different directions, and I don't want to traverse again because this one is already affected, and it's also a starting point. I need to check. I need to just mark this to visit, right? And then I'm going to impact 0, 0 and what? 0, 2. So 0, 0 and 0, 2. And then once it finish, I'm going to just look at the next queue. So this is it. This is pretty much the solution. So again, the base case is going to be what? Image srac is equal to color. If this is true, then return the image. And I keep spell this wrong. And I'm going to say n equal to what? Image.length. And then m equal to image a0.length. Alright. So I need to have a boolean for visit. New boolean and m by m. And I need to initial my direction, new int -1, 0, 1, 0. Yes, and then 0, -1, and then 0, +1, right? So I need to create a queue. I need to put the in array. This is because I need to push the xy coordinate, right? So queue equal to new linked list. So since the current position srac is not the color, right? So I need to what? Q.add new int srac. And then I also need to check. Sorry, I also need to store my old color. Old color equal to what? Image srac. And while the queue is not empty, I have to traverse, right? And at the end, I will have to return the image. Alright, so this is pretty much it, right? So let me. Okay, so now I need to pull my current position out, right? So it's gonna be what? Position. So it's gonna be position. So it's going to be q.pull. So I need to check my current x, position x, check my current position y. And then I need to check if this is visit or not, right? If this is visit, then I don't want to visit again. So I will just case continue, right? And if the current image is also if a current cell image srac is already a new color, then you don't want to push into the queue, right? And what else? Once you finish, right? Since this is not a visit, and also this is not the same color, I need to update my current color to color, right? And also mark my current position into to visit. So it's gonna be true, right? So I need to check my direction for my neighbor. So I'm gonna say new x. It's gonna be what, x plus direction 0. New y is gonna be y plus direction 1. So I will get my new coordinate for x from from here. So imagine my current position is right here, right? And I will get my current new x for here, current new y for here, and I will have to check. I will have to check my boundary first before I add. So if new x is actually what, less than 0, or new x is equal to n, I will have to just continue. I don't want to do anything, right? And this is going to be pretty much the same idea. Less than 0, new y equal to n, continue. Alright, so if a current image is not an old color, if a current image new x, new y does not equal to the old color, which is going to be like this, 1 and 0, they are not matched, so you continue. Alright, now well, if they are not the same color, right, then you continue. If they are the same, you need to push into the queue, right? So here's it. So if the image and new x and new y does not equal to the color, so I'm gonna put q.offer new int new x new y. So what is color? What is color? Let me think about this. So the color is this one, right? So it's my current position. Is not the old color. So old color, what is old color? Old color represents 1, right? So if they are not the same, 0 does not equal to 1, right? Then I will just continue. And if the current position, which is going to be here, 1, which is not equal to the color represents 2, right? Color represents 2. So it's already equal to old color, but it's not equal to the new color. So I will just push into the queue. So it's a little bit confusing. Let me think about what I made mistake. So give me a second. Alright, just find out my mistake. So I have to use the x and y for visits as well as the current image xy. So I was making a typo for here. This is actually a typo for sure. Like I just need to check my current position, not SR and SC. SR and SC is only for the old color, right? And the current position is going to be x and y. And later on, when you push into the queue, it's going to be new x and new y. So this is actually a mistake. Once again, I apologize. So submit, and it should be okay. So let's make a little bit breakpoint right over here, right? Maybe here. So it should be clear enough, and then see a debug mode. Okay. So just keep going. So you can pause at any second if you are confused. Okay, I'm going to use this one. Alright, that's it. So once again, I apologize for the mistake. So when you traverse the current cell, if this is already visit, then you continue. And also if a current cell is already equal to the color you want to assign, which is 2, then you don't need to check again because the current cell is already affected, right? And this is supposed to be the solution. So let's talk about the time and space complexity. So this is going to be a space. This is going to be a space. So it should be what? O of n times m, right? And this is going to be a time. The time is going to be what? Traverse every single one of the metric if this is a worst case, right? So this is going to be all of n times m. So let me pull out my notes, and the BFS solution is going to be this. And yeah, that's it. So if you have any question, leave a comment below, subscribe if you want it, and I will see you next time. Bye.